final example of the method of joints, I am going to solve a problem again based on a problem from the book of Merriam on statics. This is a truss like this, where the lower point here is fixed, these are joined like this by rods, and this point is also joined by rod, and this point is then fixed here at point A. So, this is a truss A, B, C, D, E, F, G and H. Notice that these lines HG, GF and EF are slightly slanted, DC and BC are vertical. This is 10 L in length, so is ED 10 L, this is 13 L, FC is 13 L, GB is 16 L, and this length is 26 L. The truss is loaded at points, see, let me make this in red, at points C and at point D by 2000 newtons each, and we want to calculate the forces on different members. Notice, since both point A and H are on fixed pins, this problem is statically indeterminate externally. Let us see how. So, if I take this structure, then there is a vertical force here, let us call it NAY, and in anticipation I am already assuming NAX is going to be to the left. Similarly, NHX is going to the left and NHY, and there is this load 2000 newtons, 2000 newtons. Then the summation Fx equals 0 gives me NAX plus NHX equals 4000. Notice that I cannot determine from this equation NAX or NHX separately. Summation Fy equals 0 gives me NAY plus NHY to be equal to 0. That means NAY and NHY are going to be opposite. The value of NAY or NHY can be obtained by applying the torque equation, and I am going to take the torque about point H, so if I apply torque about point H, this is 10 L, 10 L, this is also given to be 10 L. Then by torque equation I get 2000 times 30 L plus 2000 times 20 L should be equal to, this is NY, 26 L times NY at A, and this gives me NYA at point A equals 2000 times 50 divided by 26, that is 1000, 13 equals 50,000 over 13 newtons in the direction shown. So, this force up is 50,000 over 13 newtons, and from the Y force balance equation, the force out here, vertical force, is going to be in the opposite direction, 50,000 over 13 newtons. This is from the equation written on the previous page. What we are now interested in is, can we determine the forces on different members of the truss, and this is what we are going to do next. So, let us look at this truss. which is like this. Sorry, this is up to this point, this is vertical, this is again now this is A, B, C, D, E, F, G, H. Apparently an indeterminate problem, but let us see if we can solve for forces in different members. To start with, let us look at point E, and I am choosing point E because from there we can start solving things in a very simple manner. At point E there are only two forces. This is of course loaded with 2000 newtons each. There is a force, let us call it F ED, and there is a force F EF. Right away, if I do summation Fy equals 0, this gives me that F EF sine of whatever that angle is should be 0, and therefore F EF is 0. If F EF is 0, then summation Fx equals 0 again implies that F ED is 0. So, starting from point E, I get two answers right away, that the forces in the members FEF and FED are 0. This force is 0, this force is 0. Now, if I go to point D here, there are only two unknown forces here, FDC and FFD, and therefore, I can determine both from the two force balance equations. Let us do that. So, if I go to point D, let me again make this structure. Point D, A, B, C, D, E, F, G, H. At point D, FED is 0 and there is only one load, 2000 newtons. There would be a force FDF and a vertical force, and again in anticipation I am making it like this, FDC. There are two unknowns and both of these I can determine. Let this angle be theta, and that will be the same angle as this. This is 10L, this is 13L. Let me in fact call it theta 1, because I am going to require other angles later. By summation Fx equals 0, I get F df cosine of theta 1 minus 2000 equals 0, and that gives me F df equals 2000 over cosine of theta 1. Notice that cosine of theta 1 from here is going to be 13 over square root of 269, and sine of theta 1 is going to be 10 over square root of 269. Once I get FDF, I can also calculate FDC from the condition that summation Fy is equal to 0, and that gives me FDC minus FDF sine theta 1 equals 0, or FDC equals FDF sine theta 1, which is 2000 tangent of theta 1. Let us calculate these numbers. So, the numbers that we get are, let me make the picture again. 2000, 2000, 0, 0, A, B, C, D, E, F, G, H. So, what we have obtained is that F E D equals F E F equals 0. We obtain F D F equals 2000 over cosine of theta 1. Let me remind you, this is theta 1, this is 10 L, this is 13 L. So, which is equal to 2000 over 13 square root of 269, and F D C comes out to be 2000 tangent of theta 1, which is 2000 times 10 over 13, which comes out to be 1538 newtons. Similarly, then the F D F comes out to be 23 newtons. So, we have found the four forces F, let me box them, F E D, F E F, F D F, F D C. We found this, we found this, we have found this, we have found this. Now, we can move on to point F, because on point F, now I know two forces F F D and F E F, and two unknown forces are going to be F F C and F F G. So, with two equations I can find these forces also. Let us do that next. So, to calculate the forces on F, let us balance the forces on F. Let me make the truss again. A, B, C, D, E, F, G, H, and I have already shown you how these are the other lines. This is angle theta 1. If I look at point F, it has a force E F which is 0. It has force, do I call it F D or D F? Let me see, I call it D F, F D F acting at an angle theta 1. Then this has a force, and in anticipation I am going to make the direction down, F F G, and let us call this angle at which it is acting theta 2, and therefore, that angle is going to be this angle theta 2, and we will calculate its sine and cosine soon. Then in anticipation again, let me just anticipate that the force F C F is going to be towards the left. So, this point F is in equilibrium under these three forces F D F, F C F and F F G. To calculate sine and cosine of theta 2, let me just drop a perpendicular from here. Recall that this is 10 L, this line is 13 L, this is 16 L. So, therefore, this portion is going to be 3 L, and this length F C is going to be 109 L, and therefore, I can write sine of theta 2 is going to be 10 over the square root of 109, cosine of theta 2 is going to be 3 over square root of 109, and we have already seen that sine of theta 1 is 10 over 269 and cosine of theta 2 is equal to 13 over square root of 269. Now, summation f x at f equal to 0 gives me f df cosine of theta 1 minus f cf minus f fg cosine of theta 2 equals 0. Similarly, summation fy equals 0 gives me f df sine of theta 1 minus f fg sine of theta 2 equals 0. From the second equation, I can find f fg right away. Recall that f df was 2000 over cosine of theta 1, and therefore, f df sine theta 1 is 2000 tangent of theta 1, and f fg is going to be f df sine theta 1 over sine theta 2 that we saw from this balance equation, which is going to be 2000 times 10 over 13 times the square root of 109 divided by 10, and that comes out to be 1606 newtons. So, we have found f fg also. Having found f fg, we can now calculate f cf also, because f cf then is going to be f cf from the previous equation. If you look at this equation, is f df cosine theta 1 with a minus sign plus f fg cosine of theta 2. You plug in the numbers. F df cosine theta 1 we already know is 2000. So, this is, did we get the sign right? Let us check that. We have plus and minus. So, this is plus and this one is minus. So, that the direction that we have anticipated is already correct. If you plug in the numbers, this comes out to be 2000 minus f fg 1606 times cosine of theta 2, which is 3 over root 109, and if you calculate this, it comes out to be 1538 newtons. So, let us see what all forces have we found in the truss. This is the truss. We found this force to be 0, this force to be 0. We found this force, let me put it in red. We found this force, let me just write this first, A, B, C, D, E, F, G, H. So, we found this force F Fd to be 23 newtons. This is of course loaded with 2000 newtons this way and 2000 newtons this way, and this force is tensile because it pulls dn. Similarly, now we have found FDC, this force which is 1538 newtons. We have found FCF, which is also 1538 newtons, and we have found FFG, which is 1606 newtons, this force. Similarly, now I can go on. Now, you see, if I look at point C, the two forces 1538 and 1538 newtons are known here, and therefore, I can calculate FCG and FCB by balancing forces on point C. So, let us balance the forces on point C. On point C, there is a load of 2000 newtons acting this way. FC is a compressive force because it was pushing point F outwards. So, here also it pushes point C this way, 1538 newtons. Similarly, FCD, which is a force which was pushing point D up is going to push this point C down with 1538 newtons. Then in anticipation, we are going to have F C G acting in this way and F B C acting up. The two unknown forces here are of course F B C and F C G. Let us look at these lines. This length is 10 L, this is 16 L. So, if I look at this angle and let me call it theta 3, I am going to have F C G acting at an angle theta 3 with sine of theta 3 equals 10 over square root of 356 and cosine of theta 3 equals 16 over square root of 356. Now, we are ready to calculate F B C and F G C. So, let us do summation f x equals 0, which gives me F C G cosine theta 3 equals 3538 newtons, and therefore, F C G is equal to 3538 newtons divided by cosine of theta 3. I can plug in the numbers and get my answer. Once I have known that, I can also calculate F B C by saying that summation F y equals 0, and that in this case gives me F B C equals 1538 plus F C G sin theta 3, which is 1538 plus 3538 tangent of theta 3, which is nothing but 1538 plus 3538 times 10 over 16 newtons, which is approximately 1538 plus 5, which is 3743 newtons, and is pushing point B up, and therefore, this is compressive. So, we have calculated forces up to G C and B C. If I know other angles, I can go further and calculate all the forces in all the members.